I think I need a stool. So sometimes we'll be standing a little, it'll seem weird, we're standing close, but that's so when we cut it later, it doesn't look as goofy.
All
right, Tony Mormino with Insight Partners here with Jake Anderson with Vertical Mechanical.
Hello.
How you doing today, Jake?
Good. How you doing?
Good. Thanks for coming on camera today. We appreciate you.
Absolutely.
I'm sure you woke up this morning like I can't wait to get on that camera.
Absolutely.
That TV show.
Love going on camera.
Man, we really do appreciate it. So we're out here at the Wardman Towers. Did I say that right?
That's right.
Wardman Towers, and it's an active construction site where I think we're in Tower A.
It's Tower A. Yep.
This is Tower A, and then there's a Tower B somewhere. Where's Tower B? Yep. Tower B is right behind us here, and this is a design build job for you all. So I thought we would do a quick video, talk about design build in general, and then maybe walk around, look at some of the systems we have installed here. How's that sound?
Sounds good.
Great. So you guys are the mechanical contractor.
Yep, mechanical plumbing. Correct.
Mechanical and plumbing. And for those who aren't, familiar with the construction industry, may just be getting into the business, what is design build all about?
Okay, so design build is basically where the mechanical contractor hires the engineer directly in lieu of an architect or an owner hiring the engineer. So we're able to manage the engineer as a subcontractor. We get to work with vendors more closely, like Hobbs.
That's the way I look at it. I look at it like it's you're almost like agreeing up front to partner together to get this thing done, and you get it done a lot faster.
Right, it's faster, exactly.
And you have more flexibility. Like the typical construction method for those who don't know who are watching is what we call plan and spec. Right? There's an architect, so then there's an engineer involved, mechanical contractors, but there's plans developed. A design is put out, and it's put out to bid. Multiple bidders go in on it, and then somebody's low bid, it picks into that. But design build is a little bit different than that. So what I like about design build is the speed and the flexibility you have. And this gives you the ability to go in there and say, have you thought about these things? Have you considered this? The other thing is the partnership with the vendors, which I think is extremely important, which in this case is a shout out to Hobbs and Associates and Brett Schuck. And what you do there is you get all these different possibilities. We're going to see all different types of equipment on this job. I think there's VRF systems, there's split DOAS systems, there's an auditorium unit, and a lot of the challenges in here, and like most jobs, is where you're going to put everything. So great. So I think that was a good rundown of design build. So let's walk around and look at some gear.
Sounds good. Yep.
You did great.
Another thing I thought
it's hard.
You can talk about how
people think it's easy.
You go through a VE process.
You
can say, well, design build, there's no VE because we design it efficiently up front. So when I was just explaining and talking about, a lot of times we talk about doing VE, value engineering on a job, because in a plan spec world, the designer puts it out, but it might not make the most sense, like you said, from an installation point of view, or from a manufacturer, like we got better equipment that could do this job that you might not have thought of. Whereas when you do design build, none of that happens because everybody's working together collaboratively up front in the design, so there's no VE because all that's already incorporated into the final design.
You heard it from the man who is in charge of this job, from the Hobbs standpoint. So, all right, what do we want to look at here? So, what is this? What is this? Is this part of the? No, this is water piping here, right?
Yeah.
Hydronics.
Yeah, the biggest thing I think we got to get to is split DOAS units, I think.
Okay, I'm going to go down, if I can find the stairs.
Yeah, I'm going to...
where are the stairs? Let's see. Yeah.
Shannon Redmond, shout out on the camera. Hey. Chris Adams, getting his workout today. So is this ductwork here, Brett? This is for the OA system, right?
Yes, yeah. This would be for all the DOAS ventilation requirements. They have the VRF that's going to handle the temperature, sensible load, and then the DOAS will treat all the humidity and meet the ventilation requirements.
Yep.
So important when you have a DOAS is that you have a latent device to handle the humidity from the OA, right? You don't want to do a DOAS system without a makeup air unit.
Right. Or
I'm sorry, a VRF system without a makeup air unit.
A lot of people try to VE out those DOAS systems when you got VRF, but they really do two different things. One handles your sensible load, one handles your latent, and you got to have both.
Yeah, I say life is too short for a VRF without a DOAS system. That's my experience.
Yes. Just asking too much of it.
Yeah, for sure.
all the ductwork?
So we manufacture all those in our Berryville site. So we do all of the sheet metal in-house. So it helps with speed. We can manage the ordering. We don't have to deal with subcontractors on a day-to-day basis on trying to get all this in.
Right.
So we can kind of manage all of the ductwork going in ourselves versus trying to go out everywhere.
A third party, right?
That's great.
It saves money too because we're doing it in-house versus markup on subcontractors and stuff. So that's why we have our main distribution center down in Berryville. I think we do somewhere between 20 and 50,000 pounds a week. So we're churning out sheet metal.
Yep.
It's a lot of gear, a lot of metal.
Yep.
It's nice too for the GC because he's got there's no finger point. It's just like these guys are handling it all. So I like that aspect of it.
Yep.
It's all on us.
I think this job has over 500,000 pounds of ductwork in it, so a lot of duct.
500,000?
Yeah.
A lot of duct.
Gotcha. Yeah. And it's a duct-free system. That's what's funny. It's a ductless system.
Well, no, they got horizontal ducted units.
Yeah.
Throughout.
Oh, okay, that makes sense.
Yeah.
You can tell I did all my homework for this.
But that's another good point, is a lot of times in multifamily, we see a lot of vertical units versus horizontal. But again, from an equipment perspective, our horizontal units, a pretty good delta from a vertical. So that was another way we were able to help control cost and save floor space, is by mounting everything up in the ceiling, keeping that extra 9 square feet of floor space that is typically used for a mechanical closet. We got rid of that. We saved some money on the equipment and things. So that's just again, that whole design engineering, design build process that we were able to capitalize on what makes the most sense from
More square footage.
More square footage and less cost.
It's a win-win if you ask me.
Yes.
Yep.
All right. This looks like a pool.
This is the pool.
Is that a pool?
Yeah, that's a pool.
Indoor pool? Is this going to be open or?
Yes.
Okay, so we touring this site here, the Wardman Towers, and we walked across. Look what we found in the basement, an AAON unit. And I got Mr. AAON himself here, Chris Adams, PE.
Hi, Tony. How are you?
Chris has been gracious enough to help us today, and you've been carrying a lot of gear around. Getting your workout?
Yes, absolutely.
Good.
Yeah, I'm the pack mule today.
Awesome. Well, while we're at this AAON split system, why don't we talk a little bit about AAON split systems? You've been selling AAON for how many years?
Coming up on 20.
20 years. You've seen a lot of changes over the years,
Significant changes, absolutely.
Yeah. So we're looking at a condensing unit here, 20 ton.
Okay.
And then we've got the air handler in there, which we'll look at in a moment. I'm assuming. The air handler's in there. Where is this going to go? Is it going to go here?
Is it going to be a pad right behind us?
It's in this space.
So it's
Looks
in
like
this.
there's a pad right there back for it.
Gotcha.
Oh, yeah.
So we're in a basement, but it's ventilated.
Yes.
It's got this huge area where air is going to be brought in. Okay, so that makes sense. So common applications, Chris, for AAON split systems?
We actually see a lot of split systems where they want to hide equipment, and obviously they're hiding equipment down here in the basement. So because architects don't like to see equipment, but we in the industry,
wrong with them?
we love to see
What's
equipment.
wrong with these architects?
Think about how many times just this morning we're driving in, and I was like, hey, there's a unit. And we know the units by looking at them.
Right.
So, but we definitely see that a lot. So split systems are where you don't have the room to put a package unit somewhere, so you do have to do some splits, and you have to be creative about where you're getting, because again, we still got to transfer the heat. We just got to transfer it to a place we can deal with it.
And while we're talking about locations of equipment, line lengths, Brett was talking about line lengths a minute ago, the importance of, I always like them, the closer the better.
Absolutely.
I think you like that too?
Yep, I always talk about efficiency as they're right together. Then you get less efficient. Less efficient, why bother?
Yeah.
So we always want them as close.
150, 200 feet, you got to really pay
Then we've got to
attention
definitely have a different issue. So yeah, we want to stay within that 75 foot or less if we can.
Right.
But then obviously we always push that limit.
Yeah. So standard AAON 101, we have the ability to have on-off compressors. We have VCC, variable capacity compressors. We have VFD-driven compressors.
You name it, we've got it.
We got it. Modulating hot gas reheat, which is really important when you're doing dehumidification. Someone very wise recently told me reheat does not dehumidify.
Correct. We were talking about this, and reheat has nothing to do with dehumidification.
Right.
The evap coil being cold has the dehumidification. Reheat's just to make me happy and make me comfortable in the space, so I don't overcool the space. So we control RH by reheat. We control true dehumidification through the evap coil, getting down to the dew point. So we always want to talk back to dew point to understand what's the true moisture content we're looking at.
All right, so condensing unit, there's some compressors in here. Maybe we could open this panel up. And then we'll walk and look at the air handler real quick. So we got some compressor covers here.
Compressor sound blankets.
Some sound blankets, which is good because there's probably going to be some resonances, I would say, not far away from this unit. And we've got our controls in here, contactors. What else do we need to see in here?
Again, very simple unit. It is truly electromechanical. We've got the wiring diagram right there behind you on the wall, which is touted as one of the best in the industry.
Right.
So,
color-coded.
Color-coded, and you know where the wires are going.
That's a good thing. Okay, so condensing unit, watch your step here. Get that out of the way. The condenser coil, and then we've got our coil hookups. Why don't we walk in here and look at the air handler? Shannon, please watch your step. So this is what AAON calls a V3 air handling unit. Vertical style, I believe. Is it vertical? Brett, is this a vertical unit?
I believe it's just to be horizontal.
It's a horizontal unit. Okay.
I don't honestly remember, I guess.
So
yeah,
it's
it might be vertical. It goes out that way. So.
Yeah, because it came in pieces.
Yeah.
Yeah.
Anyway, it's either a V3 or an H3. It's got an evaporator coil, it's got a fan and some filters and a mixing box. So that's what we got going on here. So it's nice because you can ship these in sections and you can see, it's easy to bring it in the building that way. So
yeah, definitely a vertical
control
like,
section.
Yep.
So okay. All right.
Still in process of obviously getting uncrated and getting installed back on its pad.
That's right. That's right. Okay. Thanks, Chris. That was a good rundown of an AAON Split System 101. Appreciate you. All right, Brett, what are we looking at up here?
So right here we got an LG split DOAS unit. As Chris mentioned earlier, one of the biggest challenges we had is where to put equipment. And we have a lot of equipment that's going in the garage and basements. We had very limited roof space, nothing could sit outside, so we had to get very creative. We worked a lot with SCAA, Afshin, trying to figure out different design strategies of how to get DOAS fresh air into that space. Like we mentioned earlier, you got to have that latent. So
yeah,
we used a combination of the LG split DOAS units, goes up to 2,000 CFM, and then we also, I don't know if we'll see them on site just yet, but we also had to get creative with pairing up an LG condensing unit with a third-party air handler using the EV kits for larger tonnage DOAS units. Again, it's another split system that we're able to utilize that lets us hide the equipment, but yet also provide that functionality of the DOAS unit.
And that's one of the benefits of being a rep firm who's, we have different options is, you can provide different types of arrangements and equipments, and this is a very challenging job to find a place for all this stuff. So hence the 3 different types of systems in some.
Oh yeah, it's multiple manufacturers from package to splits and everything that we had to dive deep into our tool bag to try to figure this one out. And like I said, again, working with the engineer SEAA, we were able to figure out different strategies of what we had, what we could use, and what made sense. And so
it's always good to have different manufacturers to go to solve these problems.
Yeah, and that's again that design build process of collaboratively walking through and talking. LG was very good at upfront engineering with us as well when we were trying to figure out how to make different systems work, and so
excellent.
A lot of challenges.
Yeah, you did a good job.
Thanks. We'll find out in a year when it's open.
Well, we'll have to come back and check it out. Well, you've got the ducted condensers. Something to talk about. So we've got some VRF LG condensing units. Awesome. This is a serious piping job.
It is. It is. Yeah, you'll see that we use saddles here for hangers. That's to prevent the pipes from sagging over time.
Right.
We don't clamp the pipes either. A lot of our work is investigating other folks' VRF installs, and that's a common pitfall that we see is people that clamp down the refrigeration pipes, which then allow for expansion.
Right, you need to let them have a little room to breathe, right? Because they change with temperature.
Exactly.
Yeah,
So.
and we'll see it too, the crimped insulation, and then therefore you'll get condensation where they crimped insulation, so you don't have that actual half-inch
Right.
insulation when you crimp it, and all of a sudden now you got potential for metal to metal
Right.
contact, and you get that condensation leak.
Yep.
You'll see the ducted air-cooled units, though not very common. This is an application where it made sense to use the air-cooled VRF condensers. Just duct them to a louver.
Yep.
So you can actually modify the static pressure setting on the discharge fan to allow this application. So.
Right, and if you don't if you don't do that and you just blow all that hot air in here, it builds up and it increases the temperature and then it recirculates back through the condensing unit. So
it derates.
You know, whenever you have it in an enclosed, semi-enclosed area or even like an overhang, you want to get that hot air away from the condenser as much as you can. So that's a great design aspect for sure.
Yep.
Good.
Yeah.
You guys did a good job.
Appreciate it. Still working on it. Yeah. Always a work in progress.
That's right. Well, it's an amazing looking installation to me. So.
Yeah. Pipe's looking good.
All right. Anything else on these, Brett? Did you want to talk about these at all, or?
No, we have multiple floors of this.
Give you that?
Sorry. So we'll actually have multiple floors. So it's not just this floor, the floor above, and I think even the floor above as well. Again, it was very challenging finding all the places to put this equipment.
Right.
And a shout out to Ashton, the engineer that was really doing a lot of work trying to figure out how to fit all this stuff in a small amount of space, that's for sure.
They did a great job.
Yeah.
All right, so we've looked at the DOAS systems. We've looked at some of the VRF condensing units. Now maybe we could find some indoor units.
Yes.
Let's go on a hunt. Let's go find some indoor units. Take two on the indoor unit since I forgot to hit the record button. But okay, so we found one of the indoor units.
Yeah, and one of the things that is unique about the DC area is we have a height limit of buildings, which is 130 feet typically. So as you'll see, our plenum space is probably one of the smallest you'll see in the country, and typically most owners want 1 foot or less for their plenum space. So having these nice thin boxes really is a great benefit. And then with the medium static duct, you actually have enough fan power to also have some ductwork to distribute it. So you kind of get the best of both worlds of having your fan power as well as meeting this nice thin duct requirements that we have here in DC.
Right, so the indoor unit, as you alluded to before, is a medium static style unit, which,
Yes.
you know, we hear VRF, ductless split system, but sometimes they are ducted on a short run like they are in this beautiful apartment here. So this is the indoor unit itself, and maybe we could walk through the ductwork to show folks how. So it's the suppliers coming here. Before we do that, we did find the OA here earlier is decoupled, so why don't we talk a little bit about that. Sometimes it's piped into the back of the indoor units. You and I don't like that, though. We talked about that.
Yeah, so again, the DOAS is handling your latent load, your humidification. Your VRF is handling that temperature control, sensible. So meshing them together doesn't make a lot of sense to me. And then as well as if you ducted in, it can actually give you a false reading on your return. You're not getting a true return.
On a return air, if there's a return air sensor in there,
yeah,
especially if it's hitting like right on it.
Yeah.
Right.
So now we are supplying this at a neutral air. That's the purpose of DOAS, as Chris alluded to with the reheat coil. So we will be supplying this probably around 70 degrees in the summertime. So you won't really notice that, but it will trickle it in and give you that ventilation that's needed by code. But then the other problem with if you duct it in, then all of a sudden you're relying on the fan of the fan coil to then help distribute that ventilation. Whereas if you just decouple it and let the DOAS fan handle that.
I love it. Okay, so maybe we can walk through this. So supply. And Chris is going to follow us around here. Excuse me, Tim. And I think we're in the living area right now.
You got a kitchen area here.
So kitchen area will be here, and then we've got, maybe if you come around here, over here, Chris, it might be the easiest to get a whole, if you stand over in the corner, you can get a whole span of the, got 3 supply ducts, so 1, 2, 3. And then the kitchen will be right here.
Yes.
What we're talking about. And then the bedroom's over here, and there's another supply duct on the other side here, which is heading into the bedroom, right? So.
So yeah, so
nice.
Again, you got a little bit of duct work, but not a ton. So the fan will be able to handle.
And it's not flex duct.
It's not flex duct, no.
Which is good. Great. So it's a nice system for sure. High-end system for an apartment.
Yes, yeah. We see a lot of VRF in our market, multifamily. Mm-hmm. Due to space constraints is a big one. We don't have a lot of roof space. A lot of people want pools and things on that roof. So they don't want a condensing farm of the 1-to-1 splits. So a lot of places will do the VRF, which is about a quarter of the footprint of a traditional 1-to-1 split.
Right.
And so now that frees up. And then in this case, we had that same issue of not having any roof space to put equipment.
And of course, very efficient, especially when you have a heat recovery system like this one, where you can actually cool one side of the building and use the heat you take out of that side to heat the other side of the building, or the common scenarios, you're an exterior load and an interior load, which are usually different requirements. So.
And then the other thing we have going on, DC has a big push to go all electric. So they're phasing out fossil fuels. So the great thing about VRF is at minus 22 degrees, you're still getting ample heating. Whereas a traditional split, you're probably more at minus 10 maybe, or so, or 0 degrees, but you get adequate heating even in our region. So you don't have to have any kind of gas heat backup or electric strip heater or anything else to complement it. The VRF system will handle the heating needs.
Very good product for electrification applications, that's for sure, or scenarios. But let's go look at the heat recovery box since we're talking about that.
Yes.
Which is conveniently placed not in the space because.
Yeah, so we mounted the heat recovery box in a place that would reduce piping, ease of maintenance, and things like that.
Right, so if someone needed to access it, they don't have to disturb the...
Right, you're not going into a residence, apartment, that sort of thing.
There's the piping there.
Now, one thing to notice that's nice about the piping is in our systems, you want rounded bends. You don't want that sharp 90 that a typical union pipe fitters like, no, I want a nice tight 90-degree turn. We want to reduce the amount of turbulence and loss of pressure. So you want a nice sweeping. Here's a nice sweeping curve here that you can see. So you're not getting that pressure loss of a true 90-degree elbow. It's just kind of flow. And that's, I think Anderson's probably one of the largest VRF installers in the DC market.
Right.
So they have their staff has learned all these little secrets of how to make these things successful and how they work and things, and as well as what makes it economical. So you'll see some designs where they'll actually put a HR box in every single apartment, but that adds a lot more brazing, a lot more piping, wide branches. So we like the 4-port because it's small, compact. You get multiple units. and it seems to be one of the more cost-effective ways to do at least a multifamily type of application.
Yeah, agreed. Great. Thank you, Brett.
Thank you.
You did a great job, thanks.